Alright, so I'm going to work some more examples from 6.2, the trig ratios. And this example is a little bit different because they didn't draw a triangle and label it for me. They've just given me one of the trig ratios, and I am supposed to find the other 5. Now, if they don't give you a triangle, it's always a good idea to draw a triangle. So I'm going to draw my right triangle and label it. Alright, so the information that they've given me, and you can label theta up top or theta at the bottom, it doesn't matter, just make sure that your opposite is across from it. So the information they've given me is that tangent of theta is the square root of 3, or the square root of 3 over 1, which means I'm looking at the ratio of opposite over adjacent. So I'm going to label my triangle accordingly. So I've got opposite, which is the square root of 3, and then I've got my adjacent, which is 1. Which means I need to find that third side. And I'm going to call that C because that's my hypotenuse. So I know that a squared plus b squared equals c squared, or the square root of 3 squared plus 1 squared is going to equal that hypotenuse squared. When I square the square root of 3, that gives me 3 plus 1 squared is 1 equals c squared. So in this case, C, when I take the square root of both sides, I know that C is 2. Alright, so I've got all the information I need. I've got my opposite, my adjacent, and my hypotenuse. Alright, so my 6 trig ratios, I've got the sine of theta is opposite over hypotenuse. I've got cosine of theta is adjacent over hypotenuse. I was already given the tangent of theta, but I know the tangent of theta is opposite over adjacent. And then the reciprocals, I'm just going to flip these. So I've got cosecant of theta is 2 over the square root of 3. I've got secant is 2 over 1, and cotangent is 1 over the square root of 3. Alright, so there are my 6 trig ratios, and I'm given one of the ratios and I have to find the other 5. Alright, I wanted to quickly just do one of the examples in the book to ask you to use the calculator to round to 5 decimal places. The calculators that you're allowed to use for this course, the only 2 types of calculators are the TI-30X-IIS and then the TI-30XA, and I'm going to recommend the 30 XIIS, but that's completely up to you. Just make sure you're familiar with how to input the numbers and everything. You need to be very familiar with whatever calculator you're using. Alright, so the three bigs, like I said, sine, cosine, tangent, those buttons are all available in your calculator. So if I'm supposed to use a calculator and round cosine of 37 degrees, I'm going straight in. So I can just punch in cosine of 37 degrees. And I think on the TIXA, you put in 37 and then push cosine maybe. I don't know, play around with that. But when you do that, and I round it to decimals, 5 decimal places, I get 0.79864. Okay? And the reason I'm doing this problem is you're thinking, we know how to handle a calculator, because the next part of that question asks for the cosecant of 48 degrees, and you don't have a cosecant button on your calculator, but you do know what the cosecant's reciprocal is. You know that cosecant is a reciprocal of sine, so this is the same thing as 1 over the sine of 48 degrees. Right? You flip it. Alright, so when I punch this in my calculator, I'm going to do 1 divided by, and then the sine of 48 degrees, and then rounding that to 5 decimal places, that gives me 1.34563. Alright, so just be familiar with the calculator that you have to use. You know, you don't have the secant, cosecant, and cotangent buttons, but you can use sine, cosine, and cotangent accordingly. All right, I'm going to do one more from this section. And this last example I'm doing asks me to solve the right triangle. Now, if I'm solving the right triangle, remember how many parts there are to a triangle. All right, we've got 3 sides and 3 angles. So if it says to solve the right triangle, that means by the end of it, I want all 3 sides, all 3 angles. All right, and I'm going to show you a couple different approaches of how we could work this problem. You don't have to do all the ways, just whatever you're comfortable with. All right, so in this particular case, I'm given a 90-degree angle. It's a right triangle. I'm given the other angle is 75 degrees, and I'm given one of the sides is 100 degrees. So if you're given 2 angles in a triangle, the third angle's really easy to find because you know that all 3 angles add up to 180. So, or you can say it's a right triangle, so the other 2 angles besides the right triangle have to add up to 90. So if my right triangle, I've got one angle that's 75 degrees, my other angle is going to be 15 degrees. All right, so those 2 angles, all 3 of them together add up to 180 degrees. Now, let's figure out how we're going to find those other 2 sides. If I'm going to use 75, and I can use 15 degrees as well, but I'm going to use 75 degrees in this case. And let's go ahead and find the hypotenuse here. All right, so let's call the hypotenuse x. If I'm looking for this, I know that the side they gave me is opposite, and I'm looking for the hypotenuse. So let's think about that. If I've opposite and hypotenuse, what trig ratio do you think about when I say opposite and hypotenuse? Well, that's the sine ratio. So I'm going to say that the sine of 75 degrees equals the opposite over that hypotenuse. And once again, I'm going to cross multiply and solve this for x. So I've got x times the sine of 75 degrees equals 100. When I isolate x, I divide both sides by the sine of 75 degrees. And you're using your calculator here. So when you plug that in your calculator and approximate it, it's approximately 103.5. So this hypotenuse is 103.5. All right, now you have a couple choices here. One would be, it's a right triangle. I'm given 2 sides, so you could use the Pythagorean theorem, and you could solve for that third side. Or you could use this 75 degrees again. In this case, I'm going to use 15 because I found 15. And I'm going to call this other side that I'm looking for, I'm going to call that y. So what's the relationship between y and 15 degrees? Well, that's the opposite, right? Because y, or that third side, is across from 15 degrees. I'm still going to use 100, but in reference to 15 degrees, 100 is now the adjacent side. So if I'm looking at that and going opposite, adjacent, that means I'm going to use my tangent function. So I'm going to say the tangent of 15 degrees is going to equal that unknown, I called it y, over my adjacent, which is 100. And then I'm going to do the cross multiplication again, and I get 100 times the tangent of 15 degrees equals that third side. Notice that I don't have to divide anything this time because when I cross multiply, y is already isolated, and so when you punch that in your calculator, y in this case is going to be about 26.8. So that third side is 26.8. So I was given 2 angles, so I could find the third angle very easily. And then I used my trig ratios to find the other 2 sides, the unknown sides. So I solved all 3 sides, all 3 angles. And just before you stop here, just kind of think about if your answers make sense. You remember that your biggest side is across from your biggest angle. So your biggest side is going to be across from the hypotenuse always. All right, and I mean, it's going to be the hypotenuse, not across from the hypotenuse. Notice that it's 103, and then my side across from 75 degrees is 100, and then the side across from my smallest angle, 15 degrees, is 26.8, which makes sense to me.